Hey guys, today we'll be solving LeetCode number 19, remove nth node from linked list. This is a medium question on LeetCode, and it is a very good question to get started on the pattern slow and fast pointers. Now for people that don't know slow and fast pointers, essentially when you have a linked list, you use slow and fast pointers, and the purpose of these two pointers is to have one of them run faster than the other. Kind of like the linked list cycle question that I've done. That one explains it a bit as well. But for the purpose of this video, I'll show you what I mean by moving it a bit ahead so that you get the answer. Let's consider the example that they've given. 1, 2, 3, and they've said n is equal to 2. 2, that means second last, essentially, okay? So if we look at this array, 1, 2, 3, 4, 5, they want us to essentially remove 4 and then return 1, 2, 3, 5. Okay? Now, slow and fast pointers, they both start at the same position, right? And the idea is that the fast one just goes either one step ahead, one step faster, or like 2 steps faster, any number of steps faster. It depends on how you implement it, right? So we could say the fast goes 2 times faster, right? It ends up here, and then we start the algorithm such that the slow starts here, fast starts here, and by the time the fast reaches the end, our slow will be sitting at the answer. There's tricks like that, right? And I'll explain that trick more now because that is what we essentially end up using. So the idea is, if you have a dummy, okay, we'll have a dummy, and this dummy will point to 3, 4, 5, this linked list essentially, right? Now why do we have this dummy? We'll have this dummy to work. Let's just say this is a rabbit and a fox's race, okay? The fox is a bit more sly, you know, so they both start at the finishing line, right? Starting line, sorry. So if this is the rabbit, this is the fox is a bit sly, and we will take this integer that they've given, okay, and we'll just hypothetically, don't think about why this is the answer, just think about the way first, because this is one of those questions that you will learn. It won't come to you intuitively. Like, this is pretty difficult to come up with intuitively, given that all you've learned so far is like reversing a linked list and stuff. Okay, now you have a rabbit and a fox, and we'll move it this number ahead. So we'll move fox from 1 2, so it jumps, okay, took one step here, and now it's a bit sly, okay, so it cheats itself and it starts from here instead of starting from the starting line, right? And we will let this fox complete the race now, okay? So if we imagine this linked list again, I'll remove the fox from here, I'll remove the one so that's not cluttery. Now we'll let the fox finish the race, but we'll let the rabbit race as well, because the race has to start, right? So we will say rabbit now goes here, while fox moves 1 ahead, then fox moves 1 ahead, the rabbit also moves 1 ahead, then the fox moves 1 more ahead, and the rabbit also now ends up sitting at number 3, right? Now if you've noticed, the position that the rabbit is actually sitting on is 1 before the one that we want to remove. We want to remove 4, right? Now this is something, you know, next skips the node, okay? It essentially just this link so that you make like a rewired link like this, okay? But you saw that the fox moved n nodes ahead, right? The n that's given, it moved n nodes ahead, and when it reached the end of the list, by the end of the list that it reached, the rabbit was sitting at a position that was one before the one that we want to remove, right? And it's essentially just that. Okay, so in code this would be like, let's say we have a dummy, right? The starting line, we'll say this is a list node, the dummy.next, we will attach the current list that we have right now, so we'll attach the head. Then we'll say, you could name the pointers anything. I'll say fox, okay, because I explained it as a fox, so I'll say fox is dummy right now, it's a pointer to dummy. So is rabbit, it's a pointer to dummy as well. And we move the fox n steps ahead, okay? So for, let's say, blank in range n plus 1 because the last step is exclusive, so first equals to first dot next. So if it was n plus 1 3, it would cut at 2, okay? Yep, n plus 1 first dot next. So we'll move it 1 ahead, just take one step, it won't take more than that. They will do it for n times. Then while the first is not at the end of the list, okay, while first works because the 5 will be pointing to a null, so when first sits at the null, it will immediately terminate this loop. So first equals to first dot next. So like I said, just move those pointers one ahead, move those pointers one ahead. Actually, I started writing out first. I'll write fox again, my bad. Usually have a habit of calling them first and second. Okay, fox, rabbit, and we'll move the rabbit one ahead. But we're still not done, right? Like I said, the rabbit is now sitting at the node that's before the one we want to remove. So what we will simply do is rabbit now, it now points to its own dot next. So this could be null as well, it's completely fine. I'll show another example actually just to elaborate this a bit further, and we'll simply just return dummy.next because that's where head starts from, right? So we would essentially return this part of the list now. Now again, I'll show another example actually to make it a bit more clear. 1 and 2, they want the n equals to 1, let's say, so the first from the last. So they essentially want us to remove 2. We'll have 1, we'll have 2, we'll have our dummy, right? And we start here, we will move just one step ahead. So our fox will start from here while our rabbit sits here, and then the fox will cross over, the rabbit will cross over, right? And this will terminate the loop after that because the fox has reached the end of the point. But the rabbit, what is the rabbit store? Like I said, this is null, okay? Null, none in Python, okay? And we have the rabbit sitting at 1 right now. And what did we do? We just simply did dot next. So next, then join that. So rabbit now points at null. And so your output would just be this, right? Something that's not intuitive to come up with. I think you have to understand these kinds of questions. You could try with some other techniques. This is one of the cleanest ways to come up with it, right? And that's about it for this question. Thank you.